Okay, three, two, one. We're recording. All right. Max Lieben, H3X Technologies, co-founder and CTO. Thanks so much for coming on, man. I really appreciate it. This is awesome.
Yeah, thanks for having me.
So we spoke over email a little bit, and I am really impressed with the technology that you guys are building. I think that would be a great place to start. A little bit of an elevator pitch in terms of what you guys are building, what you're hoping to do in the future.
Absolutely, yeah. So at H3X, we're building the lightest integrated motor drives in the world. The end application is for electric aircraft, but also a couple other markets like motorsport and some marine applications as well. The whole concept is that we're taking the electric propulsion system and combining it into pretty much one product on the propulsion side. So that includes the electric motor, the inverter, power electronics, and motor controller, and the gearbox. So the motor, inverter, and gearbox are the three main systems, and they all are packaged into one product.
That's insane. And you're 25, right? I think we're the same age.
Yeah. I'm
Like
25, and so are my other co-founders as well.
do you ever take that step back and realize what you're doing is like kind of crazy? You know, you finished university, you got your master's, and you're building this insane tech. Like this is pretty
Yeah, no,
awesome.
I mean it's definitely crazy, and it's definitely been a wild journey so far. And I think if we do well, it will continue to be a wild journey.
Right.
But yeah, I mean, I think that there's the best time to take big risks is when you're pretty much straight out of school and you don't have quite as many commitments and responsibilities. It's the
100%.
time to go for it and see what happens. Worst case, you learn a lot, you have a good time, and then you do something else. But hopefully, you get out of it. One thing
Absolutely.
I forgot to add, it's 3 times lighter than anything that is currently on the market. Our technology enables a 3x weight reduction for a given power level. So that's actually part of where the name H3X comes from. So there's three co-founders. It's 3 times lighter than anything that currently exists, and also the H3X. The product is
Mhm.
shaped like a hexagon. So there's
That's
the
awesome.
explanation.
Well, I mean, speaking of taking risks, in our last call, you mentioned that you considered yourself more of a CTO than a CEO. You weren't the most entrepreneurial type, you said. I mean, you've got incredible credentials. You worked at Tesla, you worked at SpaceX, big names, big positions. But I would say, what is the hardest part been for you for adjusting to this kind of stuff? And I think, given that startups are a bit more in vogue now, I mean, it's glamorous for sure, but what is some tough love that you would give for this road? Because it's not an easy one.
So yeah, when I said that I'm not the most entrepreneurial of the three of us, I think that was mostly a result of the fact that when I graduated with my master's degree, I wasn't really thinking, oh, can I go start, a company? It didn't really
Right.
cross my mind. I think like a lot of people, you graduate with your degree and you apply to a bunch of different jobs. A lot of them are larger corporations, and that's just like the path that you kind of assume is the right path.
Mhm.
And there isn't always someone saying, "Hey, have you considered this possibility?" or "What about this?" And so, I guess people who maybe started more entrepreneurial than me in spirit might have immediately gone to that as like maybe I could do this, but it wasn't something that I necessarily considered at the time of graduating.
Right.
Since then, of course, I have learned by necessity, what does it mean to be entrepreneurial, and what how did I have to, expand my horizons?
For
And
sure.
so, yeah, I think in terms of the hardest part to adjust to is, you need to be very dynamic as a person. You can't just wear one hat. It's just like I'm the technology person. I'm the CTO, and that's that.
For
When
sure.
you're a co-founder, there are all sorts of things that come across your desk, all sorts of conversations that have to be had across the board of the company. So, it could be a business thing. It could be product focused. It could be marketing. It could be, I mean, there's any number of things that are wrapped into running a business that aren't just technical, right?
Right.
That being said, our whole founding team is technical. So we're all three of us are engineers. And so to some extent, we've all had to learn this. Y Combinator was a huge help in getting us started and thinking about the right things and, how to approach the business aspect. Specifically, the main things they drive home are, talk to your customers, like really figure out what you need to do to solve their problem, make something that
Hmm.
people want, and so there's a big emphasis on that. But also, Jason, our CEO, he did have his own consulting firm that he started right out of his master's degree. And so,
Hmm.
I had never seen anyone do that before. And so, that's what I mean, where like he was already kind of the entrepreneurial type right off the bat. He saw that opportunity and seized it. That's what he did until we
Right.
started H3X. So, yeah.
That makes sense. I mean, was there a domain that you never experienced before that when you did go into that CTO position, you realized how much you liked it? Like maybe it was sales, maybe you'd never done sales before and you love putting together deals now. Maybe it was public speaking, maybe it's podcasts like this.
Right, right. Yeah, I think so. I've always enjoyed the hardcore engineering, the technology. I think what I've really come to enjoy that's, I guess, newer is getting out and talking to people and really showcasing what we're working on, which I guess isn't it's not quite sales, but for example, we have gone to a few conferences recently. We were at the ARPA-E Technology Showcase here in Denver a couple weeks
Right.
ago. We were also at the Electric and Hybrid Aircraft Technology Symposium in Frankfurt just a couple weeks ago. And it's really great to, we bring along our prototypes. They fit in a carry-on, suitcase. So it's that in itself is kind of funny. 330 horsepower in a suit,
It's
carry-on suitcase.
amazing.
But really getting the prototypes in front of people, like having them like pick it up and ask us questions, and really getting to know, potential customers, potential suppliers. There's
Hmm.
very important and real human aspects to running a tech company where it is the people that make the magic happen, right? It's not the
Definitely.
technology does not kind of culminate on its own, and so a lot of it is really making those connections with your supply chain, with your customers, and especially coming out of the pandemic, it's been made very clear that that kind of face-to-face, hands-on, hold the prototype, that kind of interaction is extremely valuable, and sort of developing those relationships.
For sure. And I mean, speaking of going to conferences, interacting with people, even your co-founders starting businesses beforehand, I'm really curious to know how you've gone about hiring and recruiting because startups are a bit more in vogue now. You might be getting people that just want a job as opposed to the H3X job. How have you found undiscovered talent? I mean, some of your recruits have been from the University of Wisconsin where you did your schooling, but what have been some of your methods? What advice would you share?
Yeah. Well, I think the first one, like you mentioned, is really leverage your existing network and try to whenever you can expand that network, because a lot of times the best talent is maybe 1 or 2 degrees of separation away. And
Hmm.
so we are very fortunate because we had a combined background and experience between Wisconsin racing at UW Madison, which was the Formula SAE team,
Hmm.
both the actual students, but also all the sponsors that we had on our racing team that made the car possible. We had already established some connections in industry that way. But also, Jason and I did our master's degrees at WEMPEC, which is the Wisconsin Electric Machines and Power Electronics Consortium. So there's a vast network of both students, professors, and industry that you build in your time at a program like that. And so between those two things, we really started from a pretty good place in terms of building our company. Like you mentioned, a lot of our initial hires have been from those networks, and it's really
Right.
important when you're starting off. Your first 5, 6 employees, they are live or die, make the company succeed. But not just that; it's also make the company the way you want it to be. You're really kind of
Hmm.
setting the baseline, and I'm definitely not the person that's gonna harp on corporate culture or company culture, but
Right.
especially before I started this, but since I've been doing this, you really get a much more tangible view of how company culture plays a role in what it is, what it's like to be at work every day, and how does that affect people's productivity, and is everyone having fun, like is everyone having a good time, and even
For
when they're
sure.
not having a good time, are they learning stuff, so they feel like they are getting something out of it. So that's all very important. But to answer your specific question of maybe how do you find undiscovered talent, we have had a couple experiences with that too. And for example, there are certain candidates that maybe on paper they haven't had a job in a year, right? And so usually that's like a red flag for recruiters. But if they otherwise look like a great candidate with the right background for the position, don't make assumptions about why they haven't been working. You don't know what happened, right? So
Right.
kind of making reasonable assumptions and minimizing the number of assumptions you make when you're filtering through bajillion applicants, or figuring out who is the right person for this position. Obviously we're pretty time limited, and so we can't talk to every single person that applies for 15 minutes to really scope it out,
For
but
sure.
at least being intentional about what you are taking away from someone's resume, and making sure that you're not leaning on some intrinsic bias accidentally, and really like identifying, hey, like maybe this person hasn't had a job in exactly this field, but it looks like all these skills are really applicable. So maybe when you talk to them, they're actually going to blow you away, because maybe they haven't done exactly what you're doing, but they have all the right pieces in place to be successful.
And that's the thing. That's one thing that I wanted to ask you as well, given that you are technical. This is a technical company, it's hard tech specifically. What if you're someone like me? You're a non technical kind of person. Instead of a BS, a bachelor's of science, a bachelor's of engineering, you've got a bachelor of arts. Instead of a PhD, you've got an MBA or you've got a master of the arts. In your opinion, where do people like that fit within these organizations?
Yeah, it's a great question. So, in the beginning of starting a hard tech company in particular, it's very different than, your typical B2B SaaS, software as a service,
Right.
basically app focused companies that are out there, of which there are many, many, many companies like this. And part of the main differentiation is that from the beginning, there can be a lot of, I guess, marketing and PR and all these aspects that all businesses have, but compared to hard tech, in the beginning with a hard tech company, you are heads down focused on like, let's get this product to work. Of course, you also have to be talking to your customers and making sure that you're solving their problem.
Right.
But beyond that, you're not. Well, at least in our view, you shouldn't be going out and plastering, your amazing thing that you have no idea if it actually works yet,
Right.
everywhere. There is some amount of gravity you need in your initial fundraise, and there's some PR involved in that. But we
Mm,
took the approach that we weren't going to start going to conferences and trade shows until we have a pretty good handle on our performance data. So
for
we
sure.
recently got to 70% of our continuous power target with our third prototype. And so while we're not all the way to our 100% of our power goal, we've been making significant progress. We've been proving it out. It's not a paper design, it's real. And for us, that was important, because now when we go to those trade shows and make those connections, we have the physical prototype, and we can say, hey, like this actually did 140 kilowatts on our dyno. And we think that makes a lot bigger impact. And so tying it back to the type of people you need to do something like this, I think the involvement of the non-technical people maybe comes at a slightly different stage for a hard tech company than for other software companies. I mean, especially
Right.
software companies that are consumer facing, then it's like a whole different world. And you need all sorts of people immediately from the beginning in order to collect the user base, right? But for us, we were heads down, build the technology, prove it out, to the point where you see a clear path to achieving your goals. And
Right.
then, you can start bringing in more people and saying, okay, maybe we need a business development person to take on the mantle of having a lot of these conversations, with potential customers. Of course, the founding team, we always like to be involved in those conversations too. But you start to see like, oh yeah, like this person could really help us out in this area, and they don't have to necessarily be super technical to make an impact. It's just, I think, it happens at a bit of a later stage for a hard tech company.
That makes sense. And when you say later stage, do you feel that that's the technology itself being able to go to market? Do you feel that that's a certain level of funding? I mean, some of these projects that we hear about these days have hundreds of millions of funding and they're still in the prototype stages. What's your opinion there?
Right. Yeah, I think it's a combination of factors. Personally, I think that technology development milestones are an important part of that, just because you have a limited amount of funding initially, from your seed round, and
Hmm.
I think you need to prove to yourself that you can get to the minimum viable product first and foremost, and then from there you can say, okay, maybe we can allocate some of this funding to do some amount of business development or a little
Right.
bit of PR and some marketing, because that does, of course, that's important. It's just a matter of when, and depending on your product and kind of your timelines, maybe it makes sense to wait to hire on a significant number of non-technical people until
Hmm.
after Series A. There's also, just
Right.
a matter of, you know, uh, your
Case by case
ability to,
basis. I know
yeah,
what you mean. Yeah.
exactly. Yeah. So,
That makes sense. Well, I'm going to combine two questions here because your team was recently featured in Techcrunch. Amazing. I saw the coffee mug by the motor. It was really
yeah.
cool. Where did kind of the expertise from your previous ventures come into play? And then how did you iterate?
yeah. So, the way that we kind of tackled this problem, the problem being, how do you make electric propulsion light enough to power reasonably large aircraft like a narrow body jet? Those are the ones with 3 seats on each side and one aisle, right?
Hmm.
And our approach from the beginning was, let's dig into the fundamentals here. Let's not jump into optimization or get lost in any fancy software. Let's just sit down and figure out where are the bottlenecks in the technology. What's preventing the current state of the art to get from 3 to 4 kilowatts of power per kilogram of mass to where it needs to be, which is closer to 12 kilowatts per kilogram, and that's
Could
kind of
could you
H3X's
explain that
goal.
as well? Some of the
Yeah,
kilowatts per kilogram terminology.
yeah, absolutely. There's been a few papers and studies done. One of them was by the Department of Energy Advanced Research Projects Agency, and they basically laid out an outline that said, okay, if we are going to decarbonize aviation, here's what the energy storage needs to do, and that
Hmm.
means batteries, it means fuel cells, maybe it even means series hybrid, with a gas turbine driving a generator, and then having the rest of the powertrain be electric. So they're like,
Right.
here's what the energy storage side needs to do, but also here's what the electric propulsion system needs to do. And for that, there are two main factors. There's how efficient is the electric propulsion system, which is a purely energy conversion metric. If I put 100 kilowatts in, how many kilowatts am I getting out, and how much
Right.
is lost to heat in between, right? And
Gotcha.
so
Okay.
typically electric propulsion systems are over 90% efficient, but every percent matters. Every percent of energy you're not losing to heat is energy that you either do or don't need in your energy storage, right? So
Right.
if you're 5% more efficient, maybe you need 5% less battery, or maybe you need even less than that due to compounding effects. But then the second metric that's important is the specific power, or a lot of people say power density. So specific
Right.
power is kilowatts per kilogram, so it's power output divided by mass of the system. And then
Okay.
power density typically refers to the same thing, but instead of power divided by mass, it's power divided by volume. Um, and the reason it matters is, specifically for aircraft, but also for other applications, you need a lot of power. You need a lot of power to take off. You need a lot of power to climb. And in the case of larger aircraft, that might be megawatts of power. And
Right.
so when you're talking, a few kilowatts per kilogram, but you're in the megawatt class of power level, you're talking like thousands of kilograms of just electric motor, inverter, gearbox, all these other components that are pretty heavy. And the thing is that while traditional turbofan, high bypass ratio engines, which are like what you'd find on your typical planes that you fly around on, slung under the wing, those
Mhm.
are pretty lightweight for what they can do. The thing is that their energy storage is super lightweight. So jet fuel
Right.
is far and away more energy dense than any other electric fuel, like a fuel cell electric system or a battery electric system.
Got
And
it.
so, in order to get the whole plane to do what you want it to do, which is to say, carry this many passengers or this much cargo
Mhm.
over this distance, you need to control how much mass is required to achieve those goals. And some of it's going
Right.
to come from how heavy is the fuel cell or the battery, and some of it's going to come from how heavy are the electric motors.
Yes,
And
for
this
sure.
is the gap between traditional, Jet A combustion fuel systems and electric is pretty large because there's currently this big gap in how heavy electric motors are versus those turbofan engines, and how heavy batteries and fuel cells are versus just a tank of jet fuel. So it's a multi-pronged approach, and innovation has to come from all sides.
Right.
So we at H3X are focusing on the electric propulsion system aspect, and we have said that we're kind of energy storage agnostic. And
Mhm.
what we mean by that is that we want to see all of these forms of energy storage improve and succeed. So battery electric is too heavy for couple 100-mile flights with any significant number of passengers. That's okay though, because it's definitely able to power eVTOL aircraft that are only flying tens of miles within a city. That can be fully battery electric, and that's great.
Right.
And our lightweight propulsion technology has a role to play in those types of vehicles. But when you start going to other applications like regional air mobility, where you have
Mhm.
a couple 100 miles that you need to travel, and you have maybe 19 passengers or maybe 49 passengers, something like that. Batteries just don't cut it anymore. Even the latest and greatest batteries are too heavy because you need so much energy to carry all of those people and cargo that distance,
Right.
that the battery ends up being like the system doesn't work. Basically, it's too heavy. So then you move to fuel cell systems, which are less efficient but are much more energy dense. And so, now you're saying, okay, let's take a fuel cell system, combine it with a lightweight propulsion system, and with
Mhm.
that, the latest and greatest technology of today, we're getting to the point where you can architect a vehicle that can go hundreds of miles and be completely emissions free, assuming that the hydrogen infrastructure is there and that it's produced in a green way. So, of
Right.
course, there are always caveats, but yeah, I mean that's kind of how we approach it. Is our technology has a role to play, regardless of if it's an intra-city short hop eVTOL or if it's a longer range narrow body jet trying to go from city to city within the U.S., for example.
Absolutely. And the reason I am so optimistic about the tech that you're building is because there is the market risk, but you guys are solving that. There are so many regional airports. I think the NASA study kind of showcased that, where there's thousands of regional airports and the tens to hundreds that get used. So
Yeah, well, I think
that's
what ends up
huge.
happening is that like you have thousands of airports in the United States, and it's like 90% of air traffic goes through like 10% of the airports. Like it's
Exactly.
completely I mean it's the hub and spoke model, right? And that's the airlines have done that because it's more profitable that way. It's
Mhm.
more profitable to shuttle people through these massive hubs and pack them onto larger planes, because the operating costs of the cost per passenger per mile, or the cost per
Right.
passenger mile, is lowest by doing it like that. So what you can do when you have an enabling technology like the one that we're building is if you can get a narrow body jet to now do a couple 100-mile flight But on an electric system, the operating costs are much, much lower. We're talking like between 40 to 60% lower. The main reasons why are the maintenance of electric motors and propulsion system, electric propulsion is way, way less complicated and needs to happen less frequently than for a turbofan, engine, which has,
Right.
tens of thousands of unique parts. Every time it needs to get overhauled, the entire thing gets disassembled, or almost the entire thing gets disassembled, and then
Hmm.
in many cases, more than half of those components have to get replaced with new ones before it gets reassembled. So the cost of overhauling a turbofan engine is understandably pretty high. Whereas for an electric propulsion system, you're talking, okay, maybe every 10,000 hours or 20,000 hours, we have to replace some bearings, right? It's
Hmm.
like a completely different type of situation. Of course, you still need to inspect things at certain intervals. There's no
Right.
getting away from that. But the actual maintenance itself is much cheaper. And then, of course, electricity is a lot cheaper than jet fuel, especially right now. I mean, oil prices right now are crazy.
Hmm.
And so it really just drives home that, like, you know, how many dollars per kilowatt hour is it right now, and then how many dollars per barrel of oil is it right now, and so like, how are those competing, and what are the cost
100%.
trade-offs. And so when you combine those two factors, those are the two main factors in the operating cost in terms of cost per passenger mile. And so that's kind of the whole business case. It is there already. If we can utilize these airports that already exist, that are in smaller towns or cities that are closer to people, so they don't need to travel an hour to an airport, then
Exactly.
we can make these routes profitable again, which of course the airline wants. The airline wants to be able to run these routes because they can make money doing that. They just don't have the
Hmm.
technology to do it yet. So that's kind of where we come in.
That's awesome. Your team has 300 million in LOIs, which is insane. I believe you did that in under 18 months as well, which is very great growth. Um, it sounds like the market risk is mitigated because here's all this infrastructure that can be utilized if an efficient way of using it is created. It sounds like technical risk is the hard part. And I would love for you to explain that a little bit more. You mentioned that energy storage agnostic is a big thing for you. Does that open up the door to more technical risk, or does that make it easier to pivot if things
Yeah.
change?
Yeah, that's a good question. So, yeah, certainly, we think the business case is there, and it's pretty solid. There is definitely it's kind of the traditional electrification concept of it's not a matter of if, it's a matter of when. And in our opinion, with our technology, we can make that when much sooner than it would be
Right.
otherwise. So it's sort of accelerating that transition. Yeah, and with, of course, with the LOIs, that also is a big de-risk on the business case. There is definitely demand for a product of this caliber. That's the whole reason we're doing this. And so, like you said, it comes down to, okay, what is new about the technology, and what risks are associated with that. So the way that we manage technical risk is we take at least in this initial stage of proving out the technology, is we take the 80-20 approach, where we say, okay, let's spend enough time in our simulation tools, our analytical models, to convince ourselves that you know this thing is going to do what we think it's going to do, right?
Right.
Whatever that may be. There are a lot of different things that an electric propulsion system has to do. But we're not going to sit in simulation land and try to make the most high fidelity model possible
Right.
and spend a bajillion dollars on really fancy software packages in the beginning. That doesn't make any sense. So what we're going to do is we're going to get 80% of the way to what we think is what we need to be doing with the design. Then we're going to build one, and then we're going
Hmm.
to learn a whole lot building one.
Right.
Our first unit had a plethora of problems, which is to be expected, right? It's the first time we built it. There are a lot of things we didn't know, right? And then we found out we didn't know, which is all
Right.
part of the process. So we built that one. It did spin. It wasn't great, and we learned a whole lot from that process. And we then soon after said, okay, here are all the issues. We're aware of them. Implement some solutions. Great, let's build the second prototype. So we went and built the second prototype.
Right.
Um, every time we iterate and build a new prototype, build quality goes up substantially. We take all the learnings from the last one, roll them into the new one. And so that iterative pace is the heartbeat and the driver of the technology, increasing in readiness level. And so with our third prototype, we've gotten to 70% of our power target now,
Right.
which is, I think a testament to just how big each step change had to be, going from the first one to the second one to the third one, where the first one
Mhm.
was just pretty much able to spin, didn't produce much power. That's okay though. Whereas now we're 70% of the way there. So it's really about identifying the trade-offs and how you spend your time and resources. If we had spent all of that time in simulation land for that first prototype, it would have been 2 years later, and we would have just built the first one, and we would have realized all of those things that we didn't know we didn't know.
Right.
So that's where that iteration comes in. And now, of course, now that we have a product that's getting towards our targets, now we're going back to simulation and trying to see, okay, we're experiencing this issue. What exactly is going on? Can we correlate it to a model and then use that model to design a solution? So it's sort of being agile and being efficient with your use of your engineering resources.
Absolutely. Well, we're approaching time here. And again, Max, a huge thank you. I said I've been following your company for a while. I really did mean it. Let me ask this, because as a founder, there's so much going on. It's such a fast pace. Everything's changing constantly. What is something that you're passionate about that you don't get asked about a lot?
Yeah. Well, I am a musician, and so from a very young age, I think I was 5 or 6 when I started playing the cello. Um,
Oh, that's awesome.
yeah, and then I continued to play through, of course, high school, undergraduate,
Did you
my
play in the
bachelor's
Wisconsin
degree.
football band?
No, I did not.
Oh,
I did play in the UW Symphony though,
oh,
and
that's
so
amazing. That's
that was a
awesome.
great experience. And I think there's two important things I think when it comes to music. Everyone's heard of like, oh, kids who do music do better on their math SAT scores, which is
Right.
great. That's awesome. I don't think SAT scores are by any means the end goal, but it's a good indicator, I guess. Um, but there is something that starting to play an instrument at such a young age does to I think form your perspective on learning
Right.
and sort of the framework of learning. Part of it is being able to recognize patterns. Something as simple as that, which is when you're learning music, it's all about patterns initially, just to the structure of it all. But then there's it translates into, okay, now you're getting better at music. Someone can put a piece of sheet music in front of you and you can sight read it, right? Which means that maybe you're not going to get it all right, but you can kind of play through it and get most of it.
Right.
So the ability to have something new put in front of you, see the big picture, and then get 80% of it, like that is a very important skill, I think, throughout
Absolutely.
life and your career. The other aspect is that, in a more I guess maybe nerdy way or a more technical way, there are many different seemingly unrelated fields or topics that have actually more overlap than you might think. So when we're talking about electric motors, there's all sorts of frequency content. There's all this frequency analysis that goes into noise and vibration, but also
Right.
into the actual power production. And when you listen to music, a lot of times you're not really thinking about exactly how it was constructed or what the intent was behind it. But especially with like electronic music, for example, where people are not only making art through making songs, but they're also making art through making sounds.
Mhm.
They are kind of literally creating these instruments from scratch, and they're making in addition to the sounds or in addition to like the music that you're hearing, they're also making the instruments that make the music.
Right.
And so, music has this kind of multi-layer aspect to it that I think engineering has too. Where when you're designing a product, you're not just finding the optimal thing. You need to be asking yourself, like, what is limiting this? What are the material limits? How can I push those limits? In the same way
Right.
that you're not just trying to write a song, you're trying to make the instruments, right? And so
Absolutely.
when we go and innovate in the areas of materials or manufacturing, that's us making the instruments, and then the product is the song that comes from the instruments. So I don't know. I think that's kind of neat.
That's awesome. As someone that did EDM production and did DJing through school, that did hit home. So I think that's a great place to leave it. And again, a huge thank you, Max Lieben, CTO, co-founder, H3X. Thanks a lot, man. Really appreciate
Yeah,
it.
thanks so much for having me. Really appreciate it.